Welcome to this lecture on first order systems. This is chapter 3 of process control. The seventh part of this chapter, part 7. So in this we are going to see the response of a first order system for a pulse input. Pulse input has been discussed in detail in one of my previous lectures. Titled as I think PC22. A video lecture titled PC22 discusses in detail about the pulse input, its equations, and so on. So if you have any doubts about, if you want to clear more about pulse input, you can go through this lecture PC22 if you have not already done so. Now before we go into this, I request all of you, those who are viewing this, to kindly subscribe to this channel and please share it. Also share it to your friends. If you have any doubts or comments or any queries, please leave them in the comment section below. So kindly request you again to kindly subscribe to this channel. Well, we'll go to pulse input of first order system for a first order system. So this is a transfer function of a first order system, right? Transfer function of a first order system. And pulse input. Pulse function is a function which has got some value for a small period of time interval, 0 to t naught. At all other places its value is 0, right? So we can also describe it like a function which suddenly changes from 0 to higher value, remains there for a finite period of time t naught, this is t naught, and returns to that value, original value at t naught quickly. So this is t naught. So in this figure it is shown as x versus t. X range increases from 0 to m. M is the magnitude of the pulse. M is the magnitude of the pulse. M, magnitude of the pulse, this increase. So it remains at a new value for a fixed time interval, small time interval, t naught, and then returns to the original value at this value, at this t naught. Well, so this is input function. Now how do you find the response of this function, first order transfer function, to this input, which is given by these three equations. The input function has three values as denoted by this, but we are concerned with what happens after t greater than 0. So it will have two equations as we have described in the previous video, PC22. PC22 it has been described. So there will be two equations, one for the period t less than t naught, and second equation for a period greater than t naught, this period. So let us write these equations and find out the response. So first one for a period t less than t naught, that is this period here, this period t less than t naught. During this period the value is like a simple step function x of t. So the input is given by, for this period t less than t naught, it's the equation of a simple step input, x of t equal to m into u of t. U of t represents unit step function, m is the magnitude, and as usual take Laplace transform. X of s, Laplace transform of this is x of s equal to Laplace transform of this m by s, and substitute in the transfer function y is equal to xs into g of s. G of s is this. So if we substitute xs into g of s will give you mk by s into tau s plus 1. Now you take the inverse of this. That's been done earlier also 2 times, I think. In 2 or 3 videos it is there. The inverse of this. How to find the inverse of this? Anyway, the link for finding the inverse of this will be given below in the description. You can refer to that if you want to know how this inverse is found. So this is the inverse of this function. Inverse of mk by s plus tau s plus 1 is this. So for the period t less than t naught, for the period t less than t naught, this is a response equation. This is you may notice that this is the response of a simple step input to a first order system. This is nothing but a simple step response of a first order system, but this is here it is applicable only for t less than t naught, only up to this period. Now for t greater than t naught, next. So this is t greater than t naught. What is the input equation? Input of this pulse function is, as we had discussed in detail earlier, it is given by the difference of two functions. So this is the input equation. So this is the input for t greater than t naught. So this is the input. So this is the input equation for t greater than t naught. So how do you find the response? Usual method, take Laplace transform. U of t is 1 by s and u of t minus t naught is this. And here you will recall that if L of f of t equal to f of s, then L of f of t minus t naught, that is translation of function, this will be what? This will be f of s into e power minus st naught. So we'll use this formula here. This is known as, you will recall that this is known as translation of function. If L of f of t equal to f of s, then L of function translated f of t minus t naught is f of s into e power minus st naught. So if you use this, if transform of u of t is 1 by s, then transform of u of t minus t naught, same function u of t translated t minus t naught will be 1 by s into e power minus st naught. Now this, substitute this in the transfer function y of s, usual method, substitute this y of s equal to xs into gs, and so this is xs, multiply this by gs. If you multiply this by gs, what will you get? Gs is k by tau s plus 1. Gs is k by tau s plus 1. So if you multiply this is xs. xs into gs will be this function multiplied by k by tau s plus 1. So multiply by k by tau s plus 1 will give you what? 1 by s into k by tau s plus 1 is this, and this 1 by s into e power minus st naught into k by tau s plus 1 is this. So y of s will get the transform function, Laplace transform variable y of s is mk by s into tau s plus 1 into this minus this. Now suppose if you call this as f of s, you call this as f of s, and this again is going to be f of s into e power minus st naught, right? So next step you have to take inverse of this ys. So when you take inverse of this, L inverse, and if L inverse f of s, L inverse is f of t, then going by this equation, going by this formula, what will be f of t, f of s into e power minus st naught? The inverse of this is going to be f of t minus t naught, right? So if inverse of this is f of t, then inverse of this is going to be f of t minus t naught. And what is the inverse of this? What is the inverse of this? What is the inverse of this function? So that we already done here. The inverse of this is simple y of mk into 1 minus e power minus t by tau. So if you substitute that, the inverse of this first function, this one, inverse of this is f of t is this, y of t equal to mk into 1 minus e power minus t by tau. Then the second function inverse is same thing. If this is f of t, if this is f of t, you have to write f of t minus t naught. So the inverse of this first function is f of t, inverse of second function is f of t minus t naught. So I'm going to this t domain, t becomes t minus t naught in this equation. That's all. So if you write it, mk, same function f of t, t replaced by t minus t naught. That's all. This is f of t. This is replace t by t minus t naught in this. If this is f of t, this inverse is f of t minus t naught. So t here, t replaced by this t here, replaced by t minus t naught. That's it. Now this is a response equation for t greater than t naught. For t greater than t naught, we can simplify this. 1 and 1 cancels. Minus e power, then here 1 cancels, so this becomes plus e power minus t plus t naught by tau. So if you take e power minus t, if you take this term common, you can take this term common. We take this term common. First term I'm taking common. So minus 1 plus, what do you get here? E power t naught by tau. So this is the response equation. You can I can write it in a better way. Y of t equal to so the final response equation is this. Same thing, I had taken minus 1 here, written in a better form, that's all. So y equal to mk into e power minus t by tau into e power t naught by tau minus 1. So this is the response equation for t greater than t naught. For t greater than t naught. So this is for t greater than t naught. So we'll have two equations, two response equations, one for t less than t naught, this is response equation, and for so this is the response equation for t greater than t naught. So pulse input described by two equations for two different periods. Therefore they'll have two different response equations, but the equation itself is the function itself is continuous. Similarly, the response equation also, response function also, y of t also will be continuous, even though it has got three equations, one to be used for t less than t naught and the other one to be used for t greater than t naught. We will illustrate this equations by using a numerical, by means of a numerical in the subsequent classes. Then you'll be able to understand more. Okay, so till we see the next class, till we continue in the next class. See you. Bye.